All right. Hello, everybody, and welcome. Sorry if I startled you. Thanks for coming to our session at the end of the day here. We're going to be talking about deploying AWS Network Firewall at scale, and we're using a real-world example. So my name is Dave DeRoche. I am an AWS Solutions Architect, and I'm joined by Aaron Baer and Mike Mcginnis, who are coming from athenahealth, which is a customer that I support. The origin of this came from a deployment that they put in place as a direct result of, well, some things that they needed to do. And I don't want to steal from their thunder, so I'm going to leave it to them to tell the story. But I thought that this would make a really good story for other customers to hear, because it talks about some of the kind of trials and tribulations that they went through as they went from basically not having anything in place to having this up in production over a very short period of time. So I think it's a good story. I'm going to start us out by just doing a quick level set. So I'm going to go through just a really quick high-level overview of Network Firewall, and we'll talk a little bit about a couple of the deployment options that can go into place. This is a 300-level session, so we'll be getting into the weeds of how these deployments are done. Then I'm going to hand it off to Aaron, who will go through the movement from a centralized deployment to from a distributed deployment to a centralized deployment in their environment. And then finally, we'll go through the policy and rules that were put into place and how that evolved over time. So a little bit about Network Firewall itself. This is a managed firewall. It kind of does what it says on the tin. It's something where AWS manages the firewall for you, and then you leverage that firewall by putting things like policies and rules in place in your environment. This works for both north-south and east-west kind of deployments, and you can choose if it's going to be something that is a symmetric or egress-only kind of deployment as well. It scales automatically, so it has an auto-scaling mechanism under the covers. It's very reliable. It has a very flexible rules engine, as you'll see when Mike goes through his section of the presentation. It, like most things at AWS, is a no upfront commitment kind of thing. You can put it in place, try it out, and use whatever you need to for it. So from your perspective as a customer, you are responsible for doing things that make sense for your business. You're going to be putting the policy in place, you'll be establishing the rule sets and so forth, and you'll be defining what the topology looks like, what the architecture looks like, where you have this thing in your environment, what kinds of traffic it's going to look at, and so forth. Optionally, you can either deploy it on its own, or you can manage it using Firewall Manager. And then from an AWS side, we are basically responsible for handling the scaling of things under the covers, making sure that you've got throughput and performance that is appropriate for what you're doing, and handling things like zonal affinity. So if you are deploying in a model where you're in a bunch of AZs, making sure that the traffic goes to the right places for the right things. There are two kind of main categories of deployments. There's distributed and centralized. In a distributed deployment, you basically have firewall endpoints that are placed into each of the VPCs, and in fact, into each of the AZs in those VPCs. And those firewall endpoints are something that you point routing tables to. So the traffic gets directed through that network firewall, and it comes back and then goes to whatever destination you're going to, be it another VPC or an internet gateway or whatever. So in a distributed model, you've got a lot of endpoints. They all kind of live all over your environment based on what you're trying to do. In a centralized deployment, you're folding those things together into an inspection VPC. And that VPC hangs off of a transit gateway. So all of the other VPCs that you want to send through that inspection VPC for inspection, kind of does what it says, gets sent off the transit gateway to that VPC, goes to the firewall, runs through whichever rules make sense, and then it comes back out and goes either out to the internet or to another VPC in that environment. So those are the kind of ground rules here. So I'm going to hand it off now to Aaron, and Aaron is going to talk a little bit about an actual deployment.
Thanks, sir. Hi, welcome everyone. We're from athenahealth. And at athenahealth, we are helping to shape the future of healthcare. And we're doing that. We partner with healthcare organizations of all sizes and provide them with technology and insights and expertise to help them drive better clinical and financial results. I'm Aaron Baer, as mentioned. I am a principal member of our staff and team lead for our AWS infrastructure team. And my goal here is to get into some highly technical details of our journey from a distributed deployment of AWS Firewall to our now centralized deployment. So how can, and a big part of this is how a process like this can drive your costs lower, in fact, in many aspects. So we're deploying a distributed firewall to each VPC initially and moved to a deployment model where our inspection is centralized. So where did this start? So this is about a 4-month journey for us. And it started in December with Log4j. I think a lot of people had a lot of things that started in December because of Log4j. And middle December, I think I was just about to go on vacation. And on a Thursday, I'm pulled into our calls. We're discussing all of these things. And it became quickly apparent that we needed a really rapid solution to get some mitigation in place. Up until this event, all of our VPCs were deployed in a fairly standard model where we use NAT egress out of the internet gateway of a VPC, and there was no need for inspection at the time, and everything was basically in and out of a VPC within an account. So it was also definitely discussed and stated that we didn't really have any egress security in place. Well, we had some. Our VPCs have network ACLs. Our public subnet network ACLs are much more tight, even for egress, than our private subnet network ACLs. But we didn't have any inspection on egress to the internet. A little bit about our environment overall. We definitely operate a multi-account environment. We manage well over 200 VPCs across all of those accounts. We only operate in US, healthcare, and that sort of thing. So we do actually only also operate within 2 regions. But within those 2 regions, we deploy subnets across 7 or more availability zones, but at least 7. We also have multiple on-premises data centers. And we essentially operate 2 network zones. We have production and we have not production. Much of this has already been in place. We've kind of been operating in this space for 6 years at least. And so our network infrastructure also already had some things that are common, some things that are really important to operating a large-scale network like this. All of our VPC addresses, network address space, is non-overlapping between accounts. Every account is assigned a common /19. We break that /19 into /20s per region. We already use Transit Gateway for communication between accounts, for using our VPN and Direct Connect. We terminate those and propagate those routes into our Transit Gateway route tables already. And then a couple of key components that assisted this as a rapid transformation. All of our VPC infrastructure is in parity across all of our accounts. So we use CloudFormation, and we use CloudFormation parameters for the uniqueness of a VPC's deployment, but every single VPC and every single account in every single region is deployed from the same template. So when we did this, it was pretty straightforward. But my hook to you is we saved a lot of money as our project went on. And so we started with nothing. You can see from our graphs here across AWS Firewall, in December we didn't have anything. Log4j hit, 100% increase. We're now having to spend more money. And over the course of our journey and our story here, we were able to reduce that initial increase of cost by 98.72%. And in addition to that, the infrastructure changes allowed us to also reduce our NAT gateway resources by 96.66% because of networking dependencies that we'll discuss shortly. So overall, it was a big success. We were able to really put in place something rapidly and, through changes, make big impact on how we're using AWS Firewall and the amount of money we were spending to do that. So let's get started on setting some ground level here about how our networks are configured. At the beginning, we have a fairly standard VPC configuration. As I mentioned, they're all the same. Also, we're using infrastructure as code practices. And you can see in the before scene, it was a fairly standard VPC. We had a public subnet with a NAT gateway. We had a private subnet that then routed through the NAT gateway to the internet gateway of the VPC. Common practice, we deploy public-facing load balancers to the public subnets. Everything else goes in the private subnets. And after our first round of change, our distributed model, you can see a change here. We had to add another subnet to every availability zone within our VPC to facilitate adding the gateway load balancers for the network firewall. And when you do that, it's obvious, it is the way it is, right? The cost of network firewall is directly proportional to the number of gateway load balancers that you deploy. Similar to a NAT gateway. As soon as you deploy one, you're going to be paying for it per hour. In this distributed model, though, the one kind of benefit that we had at the time is that if you deploy gateway load balancers to the same account that has NAT gateways, that then offsets the costs of the NAT gateways, but you're still paying for your gateway load balancers. But since we had the automation in place, since we had the code ready, I was actually able to make the infrastructure changes to add the subnet and the gateway load balancers for this in about 2.5 days of development over the weekend. The word was, let's go, we need to do this. No matter what, something has to happen. And fortunately, that was able to be completed in a rapid fashion. The development was in a couple of days. Deployment of non-prod was the next day. Successfully deployed a non-prod. Awesome, let's go to prod the next day after that. And we have already, also supporting deployment infrastructure that allows us to go through each account, running the same commands to provide those updates based on our CloudFormation template changes. So as you can see, there are a couple of additions to our VPC infrastructure at this time. In the previous, it was just a private subnet, a public subnet with a NAT gateway, and an internet load balancer. Pretty simple. In this iteration, we now have a private subnet, a public subnet with a NAT gateway, and a new firewall security subnet with the gateway load balancer. And if you notice at the top, we have an addition there where we have to attach a route table to the internet gateway. And that was a bit of a new thought to the way I had originally designed our VPCs. And I think the primary reason of this is that the internet gateway itself has to know return routes into your VPC. And to do that, you can associate a route table now to an internet gateway that's attached to your VPC. a bit of a trick here, though, that you see here. Our NAT gateway isn't the next step to our internet gateway. We now have a gateway load balancer in between. And so you actually have to manage the route table attached to your internet gateway, because if you have multiple availability zones and the route of the public subnet with the NAT gateway is the gateway load balancer and not the internet gateway, the traffic has to return to the same NAT gateway that it left your network from. So with those changes, we had some challenges and some interesting things that came up as I was going through this. As I mentioned, all of our VPCs are deployed with subnets, basically /24 subnets of a /20 for the region, which leaves some space most of the time in the original private network that's assigned to the account. But it didn't really give the correct networking address space to add three or four more subnets for the gateway load balancers. So I used an additional CIDR overlay to the VPC in this 100.90 range, 100.90, 100.91, 100.92, 100.93, so that we didn't just consume that last bit of address space that we already had available for growth in our existing VPCs, but we could still put these subnets in to get our load balancers, gateway load balancers available. But we have hundreds of VPCs. We have 7 availability zones. We have now additional gateway load balancers in each one of these. So in 2.5 days, essentially deployed 1,680 firewall endpoints across all of our infrastructure. And the cost of over 1,000 gateway firewall endpoints is pretty high. So, Log4j, the word was do this, right? We don't care necessarily how much this costs. We have to put this in place. It's, it's a security priority for us. But that comes with some discussion that we'll have in a minute as well. Another gotcha was the internet gateway route table that I discussed, and the return routes to map to those NAT gateways. And the conundrum there is, in CloudFormation, the stack can give you resource IDs for the NAT gateways that have been deployed into that instance of the CloudFormation stack, but CloudFormation won't actually give them back to you in any consistent manner. So you can't easily map this NAT gateway ID is in this AZ so that my route table route entry can say, for this, I get this. The other portion of that, you need your NAT gateway ID, you need your private subnets CIDR range, so that little /24 that is the return route. And so a complication of this distributed model in CloudFormation is that we had to write some external tooling that then query the account, build a hash of that information, loop through, assign those routes into the route table. It worked in automation because you can do this one thing and then you can run this next thing, but it was definitely something that was more than just being able to do one single CloudFormation update to make all of it happen. And then also in a distributed model, you're effectively also deploying a AWS firewall and an AWS policy to attach to that firewall in every single account. So how do you manage that across all of the accounts? Well, one way we were able to do that is we centralized our rules in a centralized account and shared those rules to all of our organization via Resource Access Manager. So that was great. We put it in place, but we quickly realized it's very expensive. And we quickly also had discussion that, awesome, we did it, we mitigated what we needed to for the moment, but is it the best solution? So a few things that helped us transition into a centralized part was that we were already using transit gateway route table among all of our accounts. So we had extensive routing. We had ways that the network was able to pass traffic around amongst our entire network. And through our discussions with InfoSec and the rest of the organization, we did come to the realization that ultimately all we need to be inspecting to provide the service that we need is that we only need to inspect the egress that's actually leaving to the internet. And then we're able to put ourselves in a place of a phased migration to move through these new discoveries and move to what will end up being our final solution as we go through. As we were going through this, resources could be removed that were previously deployed, and all of our migration steps could be automated because we were already actually deploying using infrastructure as code and automated updates and deployment practices. So where did we start to go? We started to go to what is the centralized model here. So you can see on the right that we have a set of AWS accounts, and each of those AWS accounts has their own VPC. In this example, we're in a region, and we're in a specific environment, right? So this is then essentially replicated for each region that we're in and for each networking environment that we're talking about. And we're already using transit gateways, so traffic from one account to another was already just routing right through the transit gateway. Nothing had to change there. All those routes were already propagated into our transit gateway route table. We know that we didn't need any inspection between traffic that goes between our own private accounts. We were already propagating and connecting to a number of data centers using VPN attached to the transit gateway. Those routes were already in place. And so during this migration, this transition from distributed to centralized, we could put in place the inspection VPC and then affect the network by just changing routes. So traffic that has a default destination of 0.0.0.0/0 coming out of a private subnet, instead of sending it to a NAT gateway, as we used to do, we just update the route, send it to the transit gateway. You add an additional default route to your transit gateway route table, and you associate your inspection VPC to your transit gateway as well, and your default route to 0.0.0 out of the transit gateway route table is your inspection VPC. And in this model as well, we already have inspection of ingress into a public-facing endpoint by requiring application load balancers deployed to public subnets to have WAF attached. So ingress traffic to a service can still come through the internet gateway of the VPC in the account where the service is deployed. WAF is in place to provide security for that ingress traffic. We're only needing to be worried about the traffic that goes to the internet. So let's talk a little bit more about the inspection VPC itself. So in the distributed model, I had to use that additional CIDR range overlay that was kind of outside of our private network in the first place. It worked very well, but it wasn't entirely great because all of a sudden we've got this 100.90 subnet or CIDR range attached to subnets and these VPCs that have a private network space that's different than that. So we have a net new VPC that we're able to build, and with that, we can do the same thing we do in every account. We assign a /19 of our private subnet that's designated specifically for this account. We keep record of where that should live, what account it should be associated to, and then gave more flexibility to deploy the subnets out of that private subnet range. So at the end of that, each of our subnets for our inspection VPC are now sharing the same non-overlapping private network space that the rest of our entire network uses. And that's a big benefit. If at some point in the future we want to add some other inspection component to our network, it can go into this VPC. But for our use case here, we just need to implement network firewall. And so we have our 3 layers of subnets. And now you'll notice a difference in this subnet layout than the previous subnet layout, since we're able to define this one net new. Our private subnets are essentially attached with an ENI that's attached to the transit gateway. That route's then propagated into the transit gateway, into the transit gateway route tables. The next layer, we actually then do network firewall gateway load balancers. And so the route table for the first subnet is the destination of the gateway load balancer in our firewall. Inspection can happen. And then the default route for the network gateway firewall subnets is the public subnet of the inspection VPC, which holds the NAT gateway. And the benefit of this is, now that the NAT gateway next hop is the internet gateway, you don't have to manage the routes like you used to. You don't have to manage the routes the same way. You actually don't have to manage any routes at all anymore. The attached route table to the internet gateway and the NAT gateways being that that hop out, they'll route the traffic back in as you'd expect. So some of the challenges and some of the key points I wanted to kind of point out here is that simplification of the internet gateway route table was effective for us. And having the NAT gateways on the other side of the gateway load balancers was what drove that simplification. And then we were able to drop out the external scripting outside of CloudFormation to manage those things, and we're back to a single template, a single update to manage the entire network for that inspection VPC. And as we're going through this, one of the gotchas that we found is that Network Firewall Manager doesn't really work for us in this way. And a couple of the main reasons why is that Network Firewall Manager kind of wants to build its own subnets, kind of wants to manage its own resources, and you don't have much control over that. So if you're already really controlled in your network and you want to just kind of insert firewall into it, Network Firewall Manager can do it, but it kind of gets a little chunky. It didn't really work for us. And then we couldn't just inherit subnets and say we want our firewall gateways here. Like I said, it creates its own. It's expecting to be able to do that. So we didn't use Network Firewall Manager to manage our network firewall. But a benefit is, now that all of the private traffic out of our private subnets that's destined for the internet no longer had to go through a NAT gateway within the same VPC, and the NATing for that traffic was handled by NAT gateways with the inspection VPC, it gave us the opportunity to actually remove all NAT gateways from all of our VPCs. So when we deployed over 1,500 firewall gateways into every account, we still also had NAT gateways. We were also and when we transitioned to the centralized, we were able to reduce all of those network firewall gateways, gateway load balancers. But then in addition to that, we're also able to remove all the NAT gateways. And previously, we had already built into our CloudFormation that manages our VPC networks a conditional parameter of enable NAT gateways, true, false, and then a dependency within the resource creation of our CloudFormation that said, if this parameter is set to false, then don't build the NAT gateways, or remove the resources. So in our automation, in our infrastructure as code, we were able to just say, hey, turn off the NAT gateways, boom, and run an update against the VPC, and removed over 1,000 NAT gateways that we had run for years. I did mention our internet facing load balancers were already using WAF, so that was a complication that we didn't have to solve with a network firewall. And a driving factor of us being able to move the centralized was the fact that we only needed to inspect internet-bound traffic. Traffic was already being inspected between network zones, on-premise network firewall, or on-premise firewalling that had already been in place. We didn't need any inspection between AWS accounts within the same network zone as well. So all of these things allowed us to drive a phased change of approach. We were able to quickly mitigate our security issues that came up in December for Log4j. We were able to deploy very quickly to do that. It was the moment of this is more important than how much it costs until we deployed it. And the cost showed up and we were like, hey, great, but maybe that's not the right solution. It allowed us, though, to step back and identify all the pieces that we do really need in a more pragmatic and calm discussion, and ask questions of ourselves like, what is the best firewall that we need to use? Is it from a vendor? Is it from something else? Is it for this network traffic? Is it not for this network traffic? We were able to have discussions with external vendors, and one of the things we found at the time was they may have an excellent solution for network firewalling, but most of the time it was, well, you have to deploy your own EC2 instances and manage your own infrastructure, and then you run our software to provide the firewalling services. And in this critical moment, our teams were kind of constrained. Honestly, I was the person who was managing all of the infrastructure at the time, so we didn't have a lot of bandwidth to say, okay, well, we can start managing a new fleet of EC2 instances and have the time to write all the automation to install the third-party vendor software and configure it with automation and all these things. It didn't really work for us, but we were able to take that moment to have those discussions. Additionally, we didn't have to change everything all in one swoop. We were able to deploy the inspection VPCs and make sure that their infrastructure was correct. And then we were able to take the same firewall rules that we put in place for the centralized model and apply them to the inspection VPC. And then we were able to migrate just our networking as we needed to in phase changes. So we were able to just change the route for the destination of the internet to the transit gateway in all of our private subnets and see that traffic move. But we already knew that our firewall rules in place for our security assisted custom, we're definitely blocking this outbound traffic rules, additional AWS managed rules that we had set in evaluation mode. We just used the same rules for our first phase. So we knew when we pushed the traffic over there, it wasn't going to affect the existing network traffic because it was the same rule set. And then once we moved all of the networking, and then we could focus on the next iteration of our firewalling. And not only were we able to continue to mitigate the security vulnerability issue with Log4j, we were able to also decide, well, hey, here's our chance to also put in place best practices of actual default deny outbound egress for our entire network in a more controlled way. And so we were able to then work on the firewall and the policy and start building a more strict policy for these new rules that are in place. Then we were able to update that firewall and attach our strict policy using alert established at first. And so we were essentially passing all traffic through and logging all of that data so that we could then inspect our network traffic without affecting actual information. And then we were able to communicate with our developer teams for them to start looking at their own data, because we were becoming aware and starting to state that, hey, we're going to do default deny. And by default, if it's not our own domain, if it's not our own known destination and untrusted places on the internet, default is going to be, deny is going to be default. And we were able to do that using alert established on the policy first, logging and evaluating that. And then when we knew we were pretty good, when we had talked to all of our developer teams and we were ready to go, we switched our policy just by flipping alert established and adding drop established to our policy, and everything was in place. So that is kind of the technical details of the network journey. And I'm going to pass it on to Mike now at this point, and he's going to talk more about the firewall rules.
Thanks, Aaron. Hey, everybody. My name is Mike Mcginnis. I'm a principal security engineer at Athena, and I lead the public cloud security group. So, as Aaron mentioned, we've gone on this journey from decentralized to centralized. So what we're looking at, pre-network firewall, really we're looking at the NACLs and security groups as the primary filtering for traffic. It's all IP-based, right? What's the IP, what's the port, what's the protocol, and then it's allowed through. We didn't have any way to actually implement filtering based on, HTTP methods, user agents, domains, anything like that. Log4j happened, which was the emphasis to get us into network firewall. As we started through the journey, basically what we were looking at is we had to define the policy requirements. And we broke it down into define the policy scope, have minimal impact and minimal outages, and enable the developers. So Aaron touched on this, but basically the defining the scope is, are we going to do inbound filtering only, outbound filtering? Do we care about the east to west? Do we care about, internal traffic, or, what's the decision? Also, how granular do we want to get? Is just IP good enough, or do we actually want those domains? And all of that was sort of gone into the scoping of the policy set. We wanted to have minimal impact and minimal outages. As Aaron said, we were 6 years into this, so just dropping a firewall in and putting default deny in place really wasn't the best idea. Because if we broke a lot of stuff, the first thing to go would be firewall. As part of that, we also wanted to have a defined rollback strategy. As we were chunking through each of those phases that Aaron was describing, we actually had a very well-defined rollback strategy for each and every one of those. So in case the change created an issue, we would be able to roll back while we identify what that issue was and work to fix it. Lastly on the requirement was enabling the developers. We need the developers just as much as they need us. We have to provide them the logs, we have to teach them how to use the logs, and then also bring them along on the journey. Keep them updated what's our progress? Where are we in the path? What's our intention? What's the end goal? So very similar to the phases that Aaron was talking about, we also created 3 policy phases. So we created the alert policy default, then the alert policy strict, and then eventually default deny. And when I say alert policy, default, and strict, those are the actual firewall modes. So the firewall has default mode, in which it basically does rule processing in groups based on the action. So it will evaluate your passes first, then your denies, and then your alerts. In strict mode, it basically will evaluate it in strict order. So the way that the policy set is written is exactly how it's being processed. So rule group 1, rule 1, 2, 3, that gets hit first, then rule group 2, 1, 2, 3 gets hit second, and so on and so forth. So with this one, alerting default. This was the one that was pushed to all the default or the distributed policies. We initially set it up in the default rule order because that was more simplistic. We had the same firewall being deployed via CloudFormation and the RAM to share the one set of rules with all of the firewalls. What we did also is we actually, at this point in time, we put the firewall logs to CloudWatch, and we set a retention on the log group. We created a subsequent alarm to check for if a block list rule was hit. We would send an SNS over to our IR team that generated a ticket in their queue, and we were able to actually block and respond to the log4j as part of the initial policy set. It's a little misleading to say alerting default because we actually did have a handful of block rules in place, but for the most part, it was built to be an alerting policy set. Like Aaron mentioned, this was cut over to the centralized firewalls, so we could keep consistency of the policy while the entire network plumbing was actually being converted. This is what the rule set actually looked like. Very, very simplistic, right? The stateless default action is to forward to the stateful rule engine. Then we used the AWS managed rule sets in alert mode. We had an allow list, and that was sort of just to clean up the logs a little bit. We had a block list, and then there actually isn't a default action in default mode. And really, this is all it looks like. This is the sort of the default actions of the firewall. But you basically see in stateless, it's just going to forward it down to the stateful, and then the stateful is just rule order default. Below this in the console is your policy set. So moving through the journey, right? We've come into a centralized model. Now we're rebuilding the policy set to what we want it to be. So we moved this over to the centralized firewalls. As part of that, we had to remove this Suricata priority. And what that basically means is that under the hood, the firewall is using Suricata IPS IDS, and Suricata is the open source, is an open source IPS. So all of the rules are written in Suricata. One of the keywords is a priority. In default mode, the priority will set the priority of the rule within the group. So even though it's a pass, you can have different rules within pass hitting at different times. But because we're in strict ordering now, that's no longer needed, and it actually throws a policy error if you try to push the rules with it. We updated the policy set. Every firewall, again, had the same policy set. But one of the key changes in centralized versus distributed is we actually consolidated the logging to S3. And then from there, we use event notifications to push it to our SIM, and then start to leverage our SIM for the continuous monitoring and take out that CloudWatch alarm. And that really was to synthesize the alerting and logging workflows with what we were already using and what the IR team had already built out. The one thing to mention on that one is we also did provide the developers access to those logs. We provided them very granular access. So this is what the new policy looks like. Within the stateless rules, we actually did add a stateless rule set to allow trusted IPs to bypass the inspection engine. And this was, and when I say trusted, I mean truly trusted IPs. Below that, we're going to forward everything to the rule groups, to the stateful rule groups. So we have our allow list, we have our block list. Now we have the AWS managed block list. Below that is the filtered domains. So the idea here is that we really want to look at, maybe this is traffic that looks a little suspicious, or it's traffic that we're not fully vetted. So if we drop them below the block list and the managed block list from AWS, if the domain or if the IP or whatever else rules are there show up in either of the two lists above, they will actually still get blocked by the rules above and not be allowed through. If they don't show up in those, then they'll be allowed through. It's sort of a proving ground in a sense. Below that's the developer requested rules. We'll talk about the developer workflow in a little bit. And then we have the stateful default action, like Aaron mentioned, of alert established. So here again, stateless is the same. Rule order is now from default to strict, and now we have a default action of alert established. On the default deny, a lot of work went into moving from the alert strict to default deny was mostly in the background. To be 100% honest, the change was super easy because all we had to do was update the CloudFormation to add the action of drop established and do a CloudFormation stack update. That's literally it. Like, it was like three minutes in and you're done. All of the effort was in prior to getting to that point. What we did is we worked with the development teams very, very, very closely. We implemented a developer request process. We added 100 developer rules to the rule set, and this was purely based on analysis of traffic, evaluation of traffic, and discussion with the development teams to say, do you actually need to go to this health.gov site, or do you need to do this? And then we would have that discussion. We blasted them with notification and messaging. We didn't bury them to the point where they just droned us out. But it was, we wanted to be very explicit as to when what change was happening so they could expect and plan for it. We held daily office hour calls. We do have offices in India, so the office hours would alternate days so we could accommodate all of our development groups. And then again, we just modified the firewall. When we did it from a least used, least risk to most used, most risk method. Meaning we decided which of the firewalls was the least used, and if it went down because of a poor policy change, that was okay, or that was the most acceptable. We started there for the initial deployment, and as we worked through it, we moved to the final, which was our main production site. Again, the rules did not change whatsoever. The rule groups did not change. The rules just got more defined and more applicable to us. Here you can see default action now includes drop established. So where are we now? Default deny is in place across everything in our AWS ecosystem. The whole change, including Aaron's and the policy work, resulted in less than 10 medium issues. So it was not a very impactful change. We have, to date, over 120 developer requests through our process. Now we're really focusing on operational efficiencies. Literally a couple days ago, VPC prefix lists were announced, which basically allows us to group CIDRs, which I think might make our policies a little more flexible. We're also looking at refining policy sets. So as the business grows and new workflows come in, we're able to look at those more holistically. So real quick, I just want to jump into the developer workflow. So basically, what we wanted to do is make it super, super easy for developers to have a say in what traffic is allowed in their account. Granted, it falls below our block list, so we do have a say. The workflow also has gating and guardrails encoded into it, so developer can't just say, hey, I want my account to go all the way to the full internet. Give me 000 outbound, and we just say, yeah, sure, whatever. We actually have a lot of guardrails that we built into the process to alleviate some of that. It's based in Git, so sign-offs and auditing and governance is all a part of it. It's built through a pipeline, so it's quick and efficient. And the approval process, we do approve it during business hours. If there's an incident, so if there's an actual outage, the NOC can approve in our place. And then we have a process where we're alerted and notified. So when the security team comes in the next day, they can perform that assessment. So on the predefined rule variable, the policy or the rule group has what's called a rule variable. And it's basically just IP sets we, the security, define those and manage those as new accounts are created. The JSON that you see under developer submission is literally the only thing they have to submit as part of their PR. So when they create their pull request, they have to tell us the account ID and what domain, port, and protocol, domain/IP, port or protocol that they want. We review that, we merge it, and out pops our Suricata rules. So here what we're doing is we're basically using their input to create the Suricata rules that we then deploy into that specific developer rule group. I could go deep into this because it's actually super, in my opinion, it's super well designed. There's a lot of catches that we wanted to account for. But the end run is, this is what gets transformed into the firewall that allows their traffic to get passed. So policy challenges. We did a lot of work, a lot of movement throughout the journey. What we found is that default ordering is nice, but it's limiting in advanced use cases. So when we were really trying to get that alert kind of policy set to say, what are we seeing? We couldn't really get it easily. We were seeing a lot of the denies happening before the alerts would, so we were actually blocking more traffic than we had wanted to without putting in past rules above it. Domain list is a really cool feature of Network Firewall. The only gotcha is that they put a deny any at the bottom, so it's literally a whitelist. You put in your domains, you hit save, it lists out the domains in Suricata form, and then we'll put a default at the bottom. So then that basically made us convert everything to Suricata, and we only use Suricata at this point. If you want an IP, a 5-tuple, so IP port protocol rule, that's Suricata. Everything now is Suricata. We didn't change anything else. HomeNet is not RFC 1918. This one, in my opinion, is pretty funny. It's an oversight on our part, but it's a good gotcha. So when we were deployed into the distributed, the firewall actually sat in the VPC. So it took the CIDR of the VPC, so it was working fine. Because the default value of HomeNet is the CIDR's, or the VPC CIDR, when we moved to a consolidated model, the only traffic that initially passed was the traffic that originated within the VPC of the firewall. All the other traffic was not being passed appropriately, so we're like, what's going on? And then we did a little light reading, and we actually realized our mistake. So then we updated CloudFormation and put HomeNet as a defined CIDR is a rule variable into all of the policy sets, or into all of the rule groups, and it fixed our issues almost instantaneously. Capacity limits is another one. So in the network firewall policy, you have what's called a capacity limit, and this is a hard set limit of 30,000. I equate them to rules, but it's basically 30,000 rules for your entire firewall. And you allocate these to each rule group. So if you just sort of haphazardly assign them and you don't think about it, you end up either having to blow away the rule group, recreating it, or you can sort of max out. And when you get to that max out page, or the max out time, or sorry, max out capacity, you're sort of in a conundrum. So what we typically will do is we'll look at what the policy or the rule set is going to be, and then estimate what we would see the top end being, pad it another 5 to 10%, and then that's sort of the capacity for that rule group. On the other end, we always leave some unallocated, so that way we're never consuming the full 30,000. We're always leaving float, so that way if we need to add more down the road, we can. If we need to add a new rule group only to transfer the policy set around, we have that ability and that flexibility. Versus if we're stuck at that top 30,000, you sort of lose that flexibility. So the next one, the network layer versus application layer rule processing. This one is fickle. So when you're doing your rule set, if you have like allow this source to this destination for any, for all TCP traffic, you're never actually going to be able to do the analysis at the app level because it's just going to see the TCP and let it through. So it's never going to sort of filter down to the app layer and get to looking at the domains or the methods, any of the more IPS kind of rules typically won't get processed if you're passing it more at the L3, L4. So just be cognizant of your rules. Because the firewall does not do TLS decryption, it leverages the TLS server name indication extension, and not like almost everything supports it. However, less than 1% of our traffic does not support it in one way or another, or it hasn't throughout the course of our journey. And most of the time, this is resolved by updating the libraries. Sometimes we were finding teams that were using really old code bases that they just needed to update. Sometimes forcing it to use 1.2, even though their code is using 1.2, for some reason forcing it to use it, fixed it, or adding a parameter as part of the web call. So when you're doing the HTTP request, actually putting in the parameter for the TLS SNI and defining the server name that you want to go to will have the firewall recognize it. Because if your client request doesn't include the SNI data, then the firewall will never see it and it'll never match it against a HTTPS TLS rule. And the last one is not necessarily a challenge, but it's just sort of a caveat, right? So debugging on a prod firewall, we ran into this where teams would say, hey, it's working fine in non-prod, but it's not in prod. So how do we sort of handle this, or how did we handle this, right? Like, we don't want to just go into the prod firewall and start typing around and like making some rule changes to see if it fixes it, right? Also, firewall is priced on a fixed monthly cost plus additional. So ballpark figure, it's like $36,000 just to have this test firewall floating around that you use, once or twice a month. So cost might not be a viable option either. And then also, like, some things can't be replicated, right? Like, for some unknown reason, some developer, patched the system and didn't tell anybody. Like, there's just oddities that can come up. We don't like them. We don't want them to happen. But sometimes these really, can't be replicated. So what we end up doing is we actually put one rule. We basically have a top-level rule group that we use with a /32. We put it through the code, through our SCM. And that way, what we're able to do is say, okay, what's the broken system? We put that IP as a /32 in the rule. And then we have the flexibility to change just that specific rule for that specific host. And because it's all done through code and through our pipeline, it's all auditable, it's all maintainable, and it's a way for us to easily perform that, that one-off testing when needed. So that's the end of our presentation. So these are the links if you want to learn more. Thank you for coming, and have a great evening.